Okay, welcome. Today we're going to finish up graphing quadratic functions by learning the last form. We've learned standard form, we've learned intercept form. Today's about vertex form. So let's go ahead and pull our notes out and get all our materials needed and we'll get going. Remember, at any time during the video, if you're following behind, pause the video so our notes are complete. And if you're not sure on something or don't understand a concept, go ahead and rewind the video and listen to it again. All right, our daily objective, our learning objective for the day is students will graph quadratic functions from vertex form. Our action is graphing. We're graphing quadratic functions, and we're doing it by vertex form, or in this case, from vertex form. And vertex form is the easiest of the three. So let's take a look and see what vertex form is. Okay, vertex form of a quadratic function looks just like this. Y is equal to a times x minus h squared plus k, where h and k are just real numbers. One more time, y is equal to some number a times the expression x minus some number, which is squared, plus some number k. Okay, it's called vertex form because from here we can actually point at the vertex. We can identify it just by looking at it. We can say the number that follows the x minus sign, we call that h, is the x coordinate to our vertex. And the number tagged onto the end, plus the k in this case, is our y coordinate. So we can simply see it by looking at it, but to be able to point at it, it has to match this form exactly. Let's take a look at some examples. Okay, our first example could be y is equal to 2 times x minus 7 squared plus 11. In this example, we can see that our h follows the minus sign. So here's our h. So we have an a that's 2 times x minus some h squared plus, and in this case, our k is 11. So if I want my vertex, we can say our vertex is the number following the minus sign, which is 7, and our k is 11. So this particular quadratic function has a vertex at 7 and 11. Let's take a look at another one. Let's go y is equal to 1 half x, let's go plus 11 this time, squared, so there's our form, minus 7. This particular function doesn't quite match up to our form. Now a can either be positive, negative, it can be a fraction, that's okay. So our a is okay. But our h must follow a minus sign, and we don't have a minus sign. So we have to come up with an h from this. And our k must follow a plus sign, and we don't have that as either. So what we're going to have to do is rewrite this. Now it'll be equivalent, but we're going to make it match the form. And we need x minus. Now this is plus 11, we need a minus sign there, so we can write equivalent form by minusing a negative 11. Minus a negative is a positive. So now we rewrote it in equivalent form that matches our vertex form. The same with a minus 7, we can write plus negative 7. Subtracting is the same as adding the opposite. And from here, we can see that our vertex has a x coordinate of negative 11 and a y coordinate of negative 7. Okay, this is vertex form, and this is the vertex. Now we're going to use this, once we have the vertex, to go ahead and use our graphing techniques. So let's go take a look and see what that looks like. Okay, so the first one we're going to graph is y is equal to 2 times x minus 4 squared plus 3. And the first thing we need to do is identify our vertex. What is our vertex in this one? So we simply need an h and a k. We have an a. We have the minus sign, so this is our h. I'm going to go ahead and box them up. And this is our k, which is a positive 3, follows the plus sign. So we can say our vertex is at 4, 3. Okay, if we go over and graph that point, 4, 3, x is 4, y is 3. We can say our vertex is up in the first quadrant right there at 4, 3. Okay, we also know from properties of parabolas that our axis of symmetry goes right through our vertex. So having our vertex and the axis of symmetry, we can simply find another point by, well, choosing another x and plugging in and solve. Now, x's to choose, 0 works, 1 works, they all work. But the easiest one to choose for me on this one would be 1 less than the vertex. 1 less than the vertex in this case is 3. Now, if I plug in a 3, then I can say our y is 2 times x, which is 3, minus 4, all squared, plus 3. Now 3 minus 4 is negative 1. So 2 times negative 1 squared plus 3, and 2 times negative 1 is a positive 1, which in this case would equal 5. So we have another point at 3, comma 5. So 1, 2, 3, 4, 5. So x is 3, y is 5. There's our second point. Now symmetry says we have another point the same distance at the same height, so he'd be over here, and connect our dots. We now have a graph simply by looking at the vertex. So let's take a look at example number 2. Got too many open there. There we go. Okay, example number 2. Go ahead and write it down. We have y is equal to negative 3 times x plus 2 squared minus 1. Now the key here is finding our vertex. So I'll use V for vertex. And I notice right away we're not in the right form. We're going to have to do the minus and negative thing. And a quick shortcut to that is to remember that inside the parentheses, you always want the opposite. So if this is a plus 2, we're really looking for a minus 2. One more time. Inside the parenthesis is the opposite. If you look back at the previous problem, the opposite of a negative 4 is a positive 4. So you can think in terms of opposite, or you can think of terms as minus and negative 2. Either way, our h is going to be negative 2. Okay, our k follows a plus sign, that's a minus, so we can just simply add the opposite. We can say our vertex is at 2, negative 1. Sorry, negative 2, negative 1. So if I go over negative 2 and down to negative 1, means our vertex is down in quadrant 3. We can find a point the same way. Now again, I'm going to go 1 less. 1 less than negative 2 is negative 1. And that makes my math over here a lot easier. So I'm going to go negative 3. Substitute in the negative 1. And just simplify from here. 2 minus 1 is 1. 1 squared is 1. So when that's all said and done, he comes out to 1. Negative 3 times 1 minus 1 is negative 4. So my point is, when I plug in a negative 1, I'm down at negative 4. So negative 1, 1, 2, 3, 4. There he is. You know you have symmetry going right through the point. So the same height. We have a parabola opening upside down in quadrant 3. Okay, we have 2 more examples. I would like you to pause the video and try these 2 on your own. And when you're done, go ahead and restart the video and we'll go over the answers quickly. So let's go ahead and do that right now, please. Okay, hopefully you got those 2 graphed. Let's compare your graph to my graph. So once again, here we go. Once again, we need our vertex. So write V for vertex. Vertex is equal to, and remember I'm going to say it's the opposite of what's inside, and looks like I forgot to write my squares down. Let me put my squares in. There we go. Okay, the opposite of what's inside the parentheses, so that's plus 4, so our vertex is at negative 4. plus 3, it follows the plus sign. So our vertex for the first one is at -4, +3. -4 is this direction. 1, 2, 3, 4. +3. 1, 2, 3. So that puts us right about there. There's -4, +3. We need one other point. Again, any x and y you choose is okay. I like to go one less. So if that's -4, I'm going to go -3. I'm plugging in a -3, so I'm simply going to cross them out, put a -3 in here. -3 plus 4 is +1. 1 squared is 1. Four times 1 plus 3 would equal 7. So this point, we have a point at -3, +7. So there's 1, 2, 3, 4, 5, 6, 7. -3's here. We know we have an axis of symmetry right through the vertex. He's one away, so one away at the same height, and there is our graph. Okay, let's try the next one. Again, we need the vertex at the opposite of whatever this is. So let's look at where the h is. We want the opposite. It says -6. We want +6. It needs to be a plus, so plus -4. So we have a vertex at +6, -4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So every vertex has been the same, the opposite of what's inside, and the number following the plus sign. Okay, axis of symmetry goes right through it. That's just a characteristic we already know. And lastly, we just simply need another point. Okay, I'm going to go one less. So if this is at 6, I'm going to go 5. Slam a 5 in there. 5 minus 6 is -1. -1 squared is +1. This is -2 times +1 minus 4 is -6. So we have a point at 5, -6. So here's 5. Go down. Let's see. 1, 2, 3, 4, 5, 6. There's your -6. Over here at 5, symmetry says we have one right across same height. And there's the graph of our parabola. Okay, so to recap our steps, again, vertex, the opposite of whatever's inside, or whatever follows the minus sign, which method you want to use. And your y-coordinate is the k, which follows the plus sign. Sometimes you have to make it plus by adding the opposite. From there, it's plotting your point, putting your axis of symmetry, just like we've done here, and then finding one other point and using symmetry to get to your third point. So hopefully that's enough to get you going. What I'd like you to do now is we have a Khan Academy assignment. So let's go back to our calendar and work on our Khan Academy.